It just said during last period, so you need to refresh. I did. I got it. A variable or a product of numbers and variables. This one's our longest definition to. So a number, a variable, or a product of numbers and variables. That's a monomial. So it's going to look like one part. Sometimes it may look like there's separate parts to it, but it's all together one part. All right, so who can give me a number? Any number. 3. 3 is a monomial. It is one part. Who can give me a variable? X. X is a monomial. It's just X. It's one part. But we can also do a product where we have a number multiplied by some variables. So who can give me something that times a variable? So a number and then a variable. 3x. Okay, let's use another number other than 3. 4wy. Something that's being multiplied. Or we can multiply lots of numbers and lots of lots of variables. We have lots of variables. We use exponents like 5a to the 6th would be 5 times a times a times a times a times a times a times b to the 7th would be times b times b times b times b times b times b times b. Really, we're multiplying all those things, but those get classified as just one part. They are all together. Okay, so that's a monomial. All right, what's our prefix in binomial? Yeah, bi, and bi means 2. Yep. So if you're a bipartisan issue, that means it's an issue that's both for Republicans and Democrats. If you are bisexual, that means you're interested in 2 different genders. If you are a binomial, you have 2 parts. It's okay. Should be good. All right, so 2 parts, that's when we are going to be 2 parts added or subtracted. So binomial, we have 2 parts that we are either adding or subtracting. So for example, if I have 3 plus 6x, that's 2 parts. What is my first part in 3 plus 6x? 3 is one part. What's the other part? 6x. Those go together because they're being multiplied together, so that's another part. So those are really just 2 parts. We have the 3 plus and then the 6x. Okay, another example might be like 4wy minus 13xy. Are those like terms? Do they have the exact same variable parts? No. They both have y's. Do they both have the same other part? No. So these would be two different parts. So I'd have like 4wy is my first part. What is my second part? 13xy. Or we might have some some exponents in there, like 5g to the third power minus 6g squared h. It looks like a lot going on there, but it ends up working out pretty quick. So even though they both have a G and an H, are those exact same parts? No, this first one has how many G's? 3, and how many H's? 2 H's. This one has how many G's? 2 G's. How many H's? 1. So these are two separate parts. We have that 5 squared. H is the second part. So that is our binomial. Alright, so if a monomial is one part, a binomial is two parts added or subtracted. What do you think is a trinomial? 3 parts added or subtracted. Okay, so big thing here is when we do this, we have to make sure that we don't have any like terms, because if we have like terms, we could combine those into one part. And we want to make plus 9y minus 6. So what is the first part in that trinomial? The 6 is the first part? 5x is the first part. And then what? 9y. And then what's our last part? Minus 6. Yep. And with a minus, we want to make sure that that goes with that 6. So we're actually going to do a minus 6 together.
So if we start moving things around, we would want to make sure that that might...
Okay, let's just do one more. So if I have x squared minus 6x are any of those like terms? Do any of them have the exact same variable? No. xy, and what is y squared? So what would be our first part of that trinomial? The x squared would be the first part. What is going to be the second? 3y squared. Alright, so that's a monomial, a binomial, and a trinomial. So that brings us to our last vocabulary word today. And our last vocabulary word is called a polynomial. Alright, and poly usually means many. So in this case, we're going to do 1 added or subtracted. Alright, you need to trim it a little bit so that you can get it in. Come on. Is that you, Edgar? Turn your volume down. Turn your volume down. Alright, you're going to get a glue in, so I'm going to try and fit it in on this page. If yours doesn't fit in on this page, that's okay. Just do it to the next page. Okay, I'm just going to trim mine a little bit.
I'm going to bring these around a bit. You can trim it up if you want to glue in.
We're not cutting all, just if you need to.
So you should have glue. If you need a scissor, that will be in your bin as well.
There's a quick check today, yep. Alright, we'll give you about 40 more seconds to get that glued in. Standard form that I totally forgot. Alright, here we go. So we're going to start with these polynomials. These ones are polynomials, but in this case they are okay to use, so phones should still be put away. And be on Instagram later, Ayane. A little goofy in this first one. What's kind of goofy to it? And this x to the third minus 9x.
So we have all those x's, but are they the same x? Do they mean the same thing?
Nope.
So one, ooh, and we have a fraction, yeah.
Okay, it's okay to have a fraction as long as it is our coefficient. So a fraction to have. Remember, coefficient is that number in front. Yep, and there's exponents. Exponents are okay. Is this a monomial, binomial, or trinomial? Good, trinomial. There's 3 parts to it. Okay, and this first one, this next one, how many variables are present? There's 2, but what variable are we, what's the base variable in each? X. So it's okay to have just one variable in our polynomials. That's okay. These are polynomials, so these are things that do work. 97x to the 41st power minus 24x squared. Is that a monomial, binomial, or a trinomial? Binomial. It's one part minus the other part. All right, what about 8? Is 8 a polynomial? Yeah. It's underneath polynomial, so yes. So is it okay to have no variables? It's okay if it's just a number.
What would we call that? A monomial, a binomial, or a trinomial? Monomial. One part.
Yeah.
One part. It's just an 8. All right, what do you notice about this next one? It's 4 parts. Is it okay to have 4 parts? Yeah, remember a polynomial is 1 or more. So is it okay to have 4 parts? Yeah. We just don't have a name for that yet, and that's okay. All right, and this next one, what's goofy about this one? What do you see that's maybe a little different looking? A square root. Is the x squared in the square root? No. What's under the square root? Just the 20. And so that we have a square root of a number, we can do that. So a square root is okay as long as it's a coefficient, a number in front. Mm-hmm. Don't have to yell it. You're yelling loud. Alright, and then this last one, what do you notice that's kind of different? There's 3 parts, so it's a trinomial. What's kind of goofy there? Pi. Remember, pi is really just 3.14 dot, dot, dot. It keeps going on and on and on. It doesn't end, doesn't repeat. That's okay. We can have those types of numbers. We call those irrational numbers. They're numbers that don't really make sense in our brain because they go on and on and on and on forever and ever and ever and ever. Is kind of goofy to us. So these are all polynomials. These are all things that are okay within math. We're happy with them. Okay? These ones are not polynomials. These are things that are not okay to work with. That we cannot rules. The things that, well, we can work with them, sorry. It's just we're not going to work with them this year because these make things a lot more complicated. All right, in this first one we have 3 to the x power minus 2x minus x. What part of this makes it not a polynomial? What's weird about it? There's an x by itself. That's okay. We can deal with that. This 3 to the power of x, like terms would be fine. We could combine those into 1. But what we can't work with is this x. This is the bad guy here. We can have no variable coefficients. Oh, not coefficients, sorry, exponents. No variable exponents. So if you see an x that's an exponent or a y or a j, that does not work. All right, and this next one, what do you see as goofy?
Variable in fraction.
There's a variable in the fraction, which would be usually okay, but where is that variable located? On the bottom, which means what are we doing with that when it's on the bottom? Remember, fraction really means that we're dividing. So no dividing by variables. No dividing by variables. That's a no-no. Alright, what's the next thing that we see that we don't like in that next one? The square root, which a square root was okay over here. What makes this square root different? Yeah, what's in the square root? A variable. So in this one, we cannot have a square root of a variable. So no square root with a variable. What about the next one? What's goofy about that one? Yeah, the exponent is a fraction. We can't have that. Doesn't work. So no fraction exponents. All right, and then in that last one, what's goofy about it? A negative exponent. Because when we have a negative exponent, where does that end up going? Remember, what do we do with negative exponents? Yeah, it flips. So if it flips, well, where would it be? On the bottom. Can we have a variable on the bottom? Nope. So we just are going to also include no negative exponents. Alright, we have one more big idea. It's a really quick one. I know it seems like a lot today, but remember, whenever we're learning a big new idea, we kind of have a lot of information about it. So I'm going to be going to my next page. So finish up writing this page and then flip to the next page.
Some of you already moved this on your second page in order to fit it, so you can stay right below it.
All right, so the last thing we're going to talk about is something called standard form. Alright, when we learned standard form earlier, we did it with equations. And we learned standard form as that ax plus, remember when ax plus by equals c? Yep. But now this time, when we talk about standard form, we're just talking about how we write polynomials. And polynomials aren't the ax plus by equals c. So we're going to make sure that when we write our answers, we're all writing our answers the same way. Okay? So standard form means that we are going to be writing, so it's written, with exponents decreasing.
So think about what that means quickly. Written with exponents decreasing. So what are exponents? And then what does it mean to decrease?
What is it?
Going down.
Going down, yeah. So we're going to start with our biggest. So we're going to go from big to small. So an example of this would be if I have like 2x to the 4th power plus 3x to the 3rd power minus 2x to the 2nd power plus 9x minus 13.
Monomial, binomial, trinomial, or polynomial?
Yeah.
How many parts does that have?
5 parts. We don't have a word for that. We probably like a quintinomial. I would think we'd use that word quint for 5. All right, what part are we looking at this that makes it in standard form? What is the part that's decreasing? The 2 decreases to 3, to negative 2, to 9, to negative 13. What's the part we said was going to decrease? The exponent. So what's our first exponent? 4. And then it decreases to 3. And then 2. And then what's this exponent of just the x? 1. And then are there any x's with that 13? Nope. So that would just be the constant. Alright, so we have one example that we're going to do with this. Just a quick practice with this one, and then we are done with notes. You guys are crushing it. Alright, so number 1, we're going to rewrite this so it's in standard form. So it's 3x squared minus 7 plus 4x to the 3rd power plus x to the 6th power. And we want to write this in standard form.
So first let's think about what our parts are, because eventually we're going to start moving these things around. So what is one part of this that you see? 3x squared. What's another part? 4x to the 3rd. What's another part? X to the 6th. And then what's our last part? Negative 7. Negative 7.
So we want to start with the one that has the largest exponent, the biggest exponent. So which one has the biggest exponent? X to the 6th. And then we want to decrease. Now, in the one example we had before, it decreased by 1. It was really nice. It went 4, 3, 2, 1, 0. That's not always the case. So we want to go with the next biggest exponent. So what's the next biggest exponent we have? Good, that 3, the third. So we're going to put that, is that going to be a plus 4x to the third or a minus 4x to the third? Okay, so plus 4x to the third power, because there is a plus in front of it. Then what? Good, 3x to the second. Is this going to be a plus 3x to the second or a minus 3x to the second? How do you know plus? How do you know it's a positive? Yeah, when it doesn't have the sign in front of it, we can assume it's positive. All right, then what was going to come last? That minus 7. And we can either write it as plus negative 7 or we could write it as minus 7. Constants, numbers without variables, always go last. Okay, so if you need to write that there, that the constant always goes last. All right, there is a quick check today. It's about 4 problems long. The first one, you're going to do the monomial, binomial, trinomial. Really quick, before we start that quick check, maybe that can be our warm-up.
So generally when we finish up our notes, we do something called a quick check in class. The quick check will be quick. It will be short. Sometimes it's only 1 question. Sometimes it's 2 or 3 questions. That's meant to give you a really quick idea of what you understand and what you know right away today. Then after a couple of lessons, you do a longer practice in class. Okay? So the quick check you should be able to finish right now during class. You're going to go to Schoology. It's in our week 1 folder. And it's just a few quick questions to check what you understood about today.
If you need help, please ask. You should be able to use your notes to find your answers.
If anyone did not get lots of questions in the course yesterday, the code is here.
Really quick check while you do this.